Okay, so last week we started this module and we tried to do some sort of the review about what you have learned already in CA 177, and also we had two lab sheets, one on Thursday and another one on Monday in the asynchronous and the campus activity. And so probably you have gone through all the things and you know how the things work. This week we will go inside some new materials and we will continue what we have started last week. So first of all, let's start with the loop, the concept of the loop in here. Okay, so I have created some sort of presentation here for you to review the loop concept. Let me see what happens. Comments actually are executed from top to bottom. For example, when I want to run these things, and if it is my standard output, so the first thing is executed is print 2, so we'll have 2 in the output, and then 4, print 4 is executed, we'll have 4, print 6 is the next one, we'll have 6, print 8 is the next one, and that sentence is the last one which is executed. For this example, I wanted to show you in all the programming languages, comments are executed from top to bottom. That's the whole story of the programming, okay? And at this point, everything is finished. So let's go inside the while loop to see what happens exactly in here. So I'll have some statement in here. That's the general structure of a while kind of loop condition, while loop, let's say. And then I'll have a condition which is evaluated by while, and then I have some sort of, let's assume that is true this time. And if it is true, I will go inside the while loop, I will execute something, and then something, and then something, and then I will back. We have reached the end of the loop body. You remember indentation last week we talked about. We said in Python you don't have, for example in C, C++ we have parentheses, we have braces in here, which shows what comments are inside the while condition, while loop or for loop or if, anything like that. All of them are similar, but in Python we don't have that. And indentation will help us to know this line of code or a statement inside the while loop, and this one is not, because there is no indentation in here. Okay, so then here we are at the end of the loop body. This space is not important. Even we could get rid of this space, and this line could be connected to the while, but since there is no indentation, that means this line of code is not part of the while loop. Okay, so in here then we are at the end of the loop body. So the next step would be, we'll go back to the top, we'll go to the condition checking part of the loop. Again, we'll check it. Let's assume that's true. Again, we execute some statement 2, 3, 4. Then again, we are at the end of the loop body. So we'll go back to the top, evaluate the condition. Let's say it is false this time. Since it is false, we don't go inside the loop condition. We don't go for this one, this one, this one, anything in here, anything with indentation under the while condition. Okay, and then so we will jump to the next line after the while. Okay, so that's the whole story of a loop inside while, for, if, all of these things. They are a little bit different between them, but in general, that's the whole story. Okay, so that's the general case. So let's look at some specific cases of the loop. Do something n times. Use the approach when we know before entering the loop how many repetitions are required. Look at this one. I consider a counter as n equal to 3, and I want to do this stuff. So what would be the standard output if I run this code? Okay, so I set a counter to, I set a kind of, let's Don't call it as the counter. That's kind of the maximum, the time I want to run the loop. Okay, and then that's the counter. I set the counter as 0, always start at 0, and then I say, okay, while I is less than n, print I, increment I, and then back up. Always check that I is strictly less than something, and then always increase I by 1. And then this can be anything inside. We are talking about the structure of the loop. See, so we have kind of setting a counter in here, a checking of the condition in here, an increasing in an increase in I, which is a counter inside the loop, and then doing something in between. Okay, so this part of the code will be executed n times then. Why? Because I start from 0, I check it, 0 is less than n, I do something, I increase I will back here, so I will continue this loop for n time until I is less than n. For example, n, if it is 3 in here, I will do that for I0 one time, I1 the second time, I2 the third time, and then when I is 3, it is not less than 3. So I will stop it. So as you can see, since we have started from 0, so this loop will be repeated for n time. That's the whole story. And that's a line of code independent from the while loop, like we discussed before this while loop. So this will happen exactly once because that's not inside the loop, like we discussed. And then that's the place it happens when we exit the loop. Okay, let's try something, executing something. Let's see what are the variables we have defined in this code. Okay, so what is n? N is 3. Okay, we'll come here. I, what is I? I is 3. 0, I is less than n. 0 is less than 3. Yes. 2. So execute the loop body. So we'll print I would be 0. So at the output we will have 0 in here, standard output. And then we will increase I was 0, so I will increase it by 1. It would be 1. Okay, 0 plus 1, I is 1. So I will put I1 in here. That's the value of I we had here. And then back to the top. I is less than n. I was 1 now. N is 3. It is true. Execute the body. Go inside. Print I. What is I? I is 1. So in the output you will see 1. Then I will increase I. I would be I plus 1. I was 1. So 1 plus 1 is 2. So I will be changed to 2 in here. Then back to the top. What is I? I is 2. 2 less than 3? Yes, true. So I will execute the body again. So that's the third time I'm executing the body of the loop. So print I, what is I? 2. So I will have 2 in the output. Then I will increase I was 2. 2 plus 1 is 3. So I'll add I in here as 3. I'll back to the top. I less than n, I was 3. N is 3 also. It is false because 3 is not less than 3. So we'll jump exactly the line after the while. So then I will print I. Print I and n. I and n, both of them are 3 because of the last thing we have from them in the memory. And then I'll print both of them. So we went exactly step by step inside the loop, and we monitored whatever happens. We followed all the process happened inside this part, in this code, this while loop. Okay, so that was a simple example. In the case you want to do something for n time, for example, let's bring a real world example. You want to repeat the process, maybe printing the name of a student inside the class. First of all, you read how many students do you have in the class? 50. Okay, so n is 50. You start from 0. You will go there. It might be just one single thing, print the name, or maybe each student might have other fields in the name also, like the student ID, birth date, everything like that. Okay, so we can print all of them. We can repeat the process in here. So it was like that. We can substitute it in general case. Like I said, we can start from 0, check I with something, with the criteria you have. If it happens, if it is true, do something. It could be more than one line of code. It could be whatever you want. That's something, doing something in general. Increasing I and back to the top, continuing that for n time. Okay, that's the general case of this type of while loop. So you can replace something with something, and you can do anything like I said in here. That example I brought to you is a good example. Okay, so let's bring another loop example in here. Okay, we have to total 0. We will get a number, we will get a string from the input. We had it last week in the exercises, in the course material, and also in the exercises, in the lab sheet. So you'll get a, let's go through it. So let's see what are the variable values inside the memory. Total is 0. Okay, so total is 0. And then I will say standard output is 19. I will get some sort of conflict in here. Let me see. Let me see what's the story in here. Anyway, let's see what happened. Let's ignore it. Yeah, standard input. Yeah. So that's the input and that's the output. That's correct. So I'm here. So I consider total as 0. So total is 0 in here. So I will go and get something from the input. User put 19 as the input, although we have asked for the raw input, which could be a string. User has entered 19 as a string, although it is an integer, but it's okay. It could be considered as a string also. That's okay. So I'll get that string. I'll check it to see. Okay, that's string 19, not the number 19, integer 19. That's a string. And then the next step, I will go and check it if s is equal to n, which is not. S is 19. It is not end, the word end, string end. So it is not equal, so it is true. The condition is true then. 19 is not end, it is true. I will go inside. Total is total plus convert that string I have get from the user to integer. So I will I will convert that 19 string to an integer 19. So I will change total plus integer of s. So 0 plus integer of 19, which is 19, and then it would be 19. Then I will add total as 19. So 0 plus integer of 19 string, which is 19. 0 plus 19 is 19. So total is 19 then, which is an integer. Okay, and then I will get the next input. I'll say, okay, please give me another input. It gives me 7. Okay, I will have 7 as a string. I will back to the top. Is 7 equal to end? It is not. 7 as a string is not equal to end. It is true. I will come here. Total is total plus integer of s. So total 19. Total was 19 already. And then integer of 7 is 26. So total is 26 now. And then I'll get another one, which is end. Okay. I will go to the top. While s is not equal to end is not equal to end. No, that's false because end is equal to end. So that's false. I don't do anything. And I want to exit the loop. Or maybe we wanted to print something. We missed to add the print statement at the end of the code, maybe without indentation in here. So let's correct it. We'll add print total to see what happens at the end of the day. And the standard output will come here because loop is not, condition of loop is not satisfied anymore. We are finished and we should go to the next line after the while loop, which is total. And 26 in here, 26, and we are done. Okay, the code is executed. That's a very good example. Another example of doing something. You are interacting with the user. You are, last time we tried to repeat a statement something. This time we are trying to calculate something and then return that something probably to the standard output, which is total. Probably in here, maybe it could be an example of that could be in the real world, could be calculating the average of score of all the students in the class. So the total is the summation all of the score of the students, for example, which will start from 0, and probably we take the values, and this end should be something, maybe the last thing we enter as the end when we enter all the numbers, and how many times it is repeated, exactly the same number of students. And then at the end of the day we have the total summation of all the numbers, and then here just we need to divide it by the number of students. We'll get to the average, and then we can print the average. So that could be a good example, real world example of this case. Okay, so that's the pattern of loop in general. As you can see here, this starts from something to measure, a counter or something like that. Then we say if the counter is less than something, do something. What was that in our example? Or it could be something like that. We can get a string. If that string is not equal to end, then do something, get another string, and get back to the top. If the condition is satisfied, continue. If it is not satisfied, exit the loop. Okay. So that's the whole thing we reviewed. So I don't want to go through that. So that was this part of the course, which was the concept of the loops. In the loops, we want to repeat something for a specific number of times. Sometimes we know what is that number of specific times. Similar to the first example, we knew we wanted to repeat the loop for 3 times. And sometimes we don't know how many times. We continue repetition of the loop until some criteria is fulfilled or it's not fulfilled. It could be both. Okay, so that's the concept of loop. Let's go for the string and lists to see what happens there. Okay, so I'm not sure if it was here. Yeah, that was here. Okay, a string represents textual data. That's a string, combination of characters, and usually they are added by these quotes signs. Okay, so something like that. So what can we do with strings? So first of all, we can measure what's the length of the string. Length of s gives us the length of the string. The second thing we can do, we can have access to a specific location inside the string. For example, s1 means inside the string s, the second location. Why? Because like we discussed last week, it is started from 0. So that's location 0, 1, 2, 3, and 4. So when we say s1, it would be e. Okay, and so it is kind of the list in here. S is a list. Although it is a string, I have put a string, but you can look at that as a list, so you can have access to a specific location inside the list. So you can say a string S or list S from 1 to 3. 1 to 3, which is from here to here. 1 and 2. 3 is not included. 1 and 2. 0 is not. 1 and 2. Okay? And we have two strings in here. S is this string and T is this string. We want to concatenate them together. Plus sign can help us to concatenate these two strings together. So simply we should say print S plus T. Nobody expects the Spanish inclusion. Okay, so what happens here? You see these two strings are concatenated exactly right after each other without any space or something like that. That's not the code problem, that's our problem. Why? Because the first string is finished exactly in here without any space, and the second string is started right in here without any space again. When we concatenate together, like using a plus sign, they are immediately concatenated from here. So that's the result in here. although there is some space in here, but this space is not considered in concatenation. So what is the solution then? We need to add a space ourselves. We need to add a space as a string. That's another string. Okay. Even we could concatenate these guys together without assigning them to S and T. We could say this string plus sign this string, which would be similar to this one. And if we wanted to have a space in here, we could say this string plus a space string plus this string. Even we didn't need to have S and T, but usually we assign them to some variables to be able to manipulate those variables later, play with them, and make the things shorter. Okay, so you could consider then a space as a string and concatenate all of them together. Then this space will sit in here, and then you will see a more beautiful sentences in here. And we could do it in another way. We didn't need necessarily to add something like that in here. We could add as a space in here. We could say nobody expects a space, and then when you concatenate them together, the first one is something like from here to here. Okay, or you could add a space in here, then it would be the same because the second string is like that. Okay, so you are able to do all of these things. Why it is good, this option? Sometimes you read the strings from somewhere else. That's not you. You have put the strings in here. The strings come from nowhere. Okay, so then you don't have any accessibility on the strings to change them. Or if you want to change them, you need to check to see if there is a string, there is a space, or there is not, blah blah, etc. So you can say never mind, I don't care at all, so I will add a space myself in here. Okay, so that's the thing. We can concatenate the strings using the plus sign in here, like I said, and we can use this string to create some sort of space between them. So let's look at this one to see what happens. So let's work a little bit with the strings. We can get a string from the user, and what is the main goal in here? We want to print out each character of a string in the reverse order. Each character of strings in reverse order. For example, if user put hello in here, I want to reverse hello. Like instead of HELLO, it should be OLLEH. We want to reverse the string in the reverse order. So that's the loop. We will get and print it and get to here. If there is any question or something like that, please put your question in the chat room. Okay, I'll answer your question. Thank you very much. Okay, so we have this loop and we want to print them out in the reverse order. What does it at the moment? You get a string, you set the counter to 0, you say if counter is less than the length of a string, okay, then print the I location inside the string, increase I, go up and check, continue until you get to the end. Let's see, I have a question. So are we going to using the older Python for both semesters? You mean Python 2? Since we have started using Python 2 for the module you have had before this module 177, we decided to go for Python 2 also in this module. But that's okay, we can convert to Python 3. I don't see any differences, you know. They don't have that much differences. Okay, so that's the loop at the moment. This loop function prints in the order which is the output. It's not printed in the reverse order. Let's see what we want to do. Okay, so change here. To print it in the reverse order, we need to change something in here. Okay, so let's say length of s is 5. So if length of s is 5, I inside the loop start from 0, 1, 2, 3, 4. S is, for example, hello, length of s is 5, so I is 0, I less than 5, I is 0, go inside, I is 0, and then the next time I is 1, repeat another time, 2, 3, 4. So we'll repeat the loop 5 times from 0, 1, 2, 3, 4. So I want to change, when I say print s, the I location of s, that means we are going straight. We want to do the reverse. So let's calculate what could make it reverse. When we are in the 0, I as 0, what is the, how we can create 4, the last one. When we are in the I1, how we can create the 1 before the last one. If we are 2, how we can create 2. Instead of increasing, how we can decrease the counter, because we want to say print that location. How we can say that location. We need to implement on the paper sometime. That's okay. We can, because programming is understanding what's going on and then implementing that inside the code. So to understand what's going on, you can go on the paper. That's okay. And you can write down everything there to realize what is the whole story and then implement that inside the code. So we have, so if I, by increasing I goes from 0 to 4, how we can decrease that from 4 to 0? Maybe this does that for us. Length s minus I minus 1. When length f is 5, I is 0, 5 minus 0 is 5, minus 1 is 4. Length s is also all the time is fixed as 5, okay? So in here I is 1, so 5 minus 1 is 3. When I is here, 5 minus 2 minus 1 is 2. We have considered this 1 because usually we start from 0 to 4 instead of 0 to 5, instead of 1 to 5. So that 1 is for this one. And this guy is for reversing the, so for decreasing the counter instead of increasing the counter, okay? So then what we should do is, instead of saying print I, si, we should say print length s minus I minus 1. It could be something like that, okay? So that's the whole story, okay? Okay, so let's look at this example, another list example. We have an empty list. We take an input from the user. We say if the input is not n, append s to a, and then get another one, continue until you take actually the end string. When you are finished, go inside this and reverse the words you have get in here, okay? So we can continue this. So I'm at the end of this guy. Probably you can repeat that, you can evaluate that yourself. So you understand what's going on in here. You get an input, it's not equal to end, you append it. What does mean the append? That means the string you have get put inside that list. Let's say the first string I get is hello. So hello is equal to end? No. So append that string inside this list. So put hello in here, get another one. So the next one, let's say it is word. I'll come back here. This is equal to end? No. Append the string you have to a, which is word. I will put in here word, which would be hello, comma, word, and then take another one. Continue, continue, continue. When it is end, don't do that. Don't append that inside a and exit. So I have then a. A is a list of multiple strings. Hello, word, and blah, 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 etc. So what is the length of a? Something. Let's say we have accepted, we have received 5 different strings inside here. So we have 5 elements inside a. So length of a is 5 then. So we'll set counter I as 0, 0 less than 5. So we'll print content of this guy in the reverse direction. We'll say length of s. Yeah, there is a mistake in here. It should be a. Length of a minus I minus 1. This is the same. This is the same as the last example we had. So what was the last string you have received? You print it first, increase I, go top. It is less than length. Yes. You'll go here. You'll take the next one before the end, print it, and you'll continue until you have printed everything in here. So we have added these examples, and you see, using this example, we can do anything we want. Okay, so that was the list, the strings, and still we had some while loop, etc. Combination of all of these things. Okay, let's go to the functions and modules. Let's see what happens in here. So that's kind of a note and lecture in here. So what is the story of the function, some of you may be familiar with the length. What is the meaning of the function? Already we have had, if we have in programming, computer programming, any language, if we have something, a subroutine, let's say multiple line of codes, which we call it subroutine, and you want it to be repeated more than once, maybe in your code, in different places you want to use it. Imagine that multiple line of code is 10 line, okay, and you're going to use it maybe 5 times in the code you have, in the program you have, and then that means 5 times 10 is 50 times 10 is 50 line of code you will have inside that. So what would happen if you can define it inside a function, and instead of 10 line of code you will have just one line, which is the function name, and whenever you want to use that 10 line of code you will use that just single line. So what would happen? First of all, the number of lines inside your program, your code, is much less than the number of what it was before using the function, and also in terms of readability it is completely easier to read the code instead of reading all line of code again. Okay, so that's the whole story of using the function. So we have had also already some example function, for example length n, input, raw input. These guys are called built-in functions. They have had these kind of functions already, okay, and we used to use them. But we can define our functions ourselves. For example, consider we want to calculate the square of a number. So the square of number is number times itself. So we can define something like that. Okay, so let's, again, we are writing a code to take the it wants to calculate the standard deviation, variance, everything of the score of a student inside the class. Already we discussed about calculating the average of the students' scores. Okay, so this time we want to calculate the variance. For variance we need to calculate the subtraction of the student score minus the mean, and then square it, then sum them up, then divide them up by the number of students. Okay, so we need to have some sort of a square. If we wanted to add all this line of code, a square, it was too much. So we can define the function. So whenever we want to calculate the square of something, just easily we can call the function we have defined already. Okay, so we have defined a square as a function in here, and if I want to print a square of 3, I don't need to say a square of 3 is 3 times 3, because I need to say square 3. In this case, it is just one line of code. You might say it doesn't make that much sense, or maybe it's not that much saving to use a function, a square 3, instead of sq is equal n times n. Yeah, you are correct. But we'll have lots of cases which you are facing lines of code, and you can make them short just with just one line of code, which is the name of the function. Okay, here it should be a plus sign. I will change it later. So a square of 5 plus a square of 6. So that's another way of calling squares, functions. You can call the functions. Okay, so that's the reason, that's the definition of a function and why we use the function. Let's go inside the function definition. Consider again this example. This function definition, we have a keyword def which comes in here. Whenever you want to define a function, you should start with def, def, define of something, and then after that you should put a name for that function. In this case, the name of our function is square. That name has kind of a regulation all the time. You know, in programming we have some restriction for the names. They shouldn't be the name of the things already we have used in the program, in the language. For example, we have length, we have input, so you are not allowed to define a function with the name of input, for example. You should consider that. Okay, the following parentheses are required, so definitely you need to have a parenthesis in here. Within the parentheses we list 0, 1 or more symbolic names for the function parameters. This thing is called function parameter, and we can add 0, nothing, 1, 2, 3, whatever we want. When it is nothing, that means the function doesn't receive anything and just does something itself. When it receives some sort of the names inside it, parameters, let's say, so that means function will work on those things and create some sort of the output for that. Okay, these symbolic names are like variables, except that their value will be provided only when the function is called. For the square function, there is only one parameter n. Finally, on that line, as with if statement, we need to have a column. We need to have a column. So that's so simple. Def, name of function, parentheses, that's essential. Nothing or something divided and separated by comma, and then a column. Okay, that's the definition. And then you will go inside the body function. Indentation is considered again in here. Any number of line of code you want to put, and then you will have a return. That return will send back the result of whatever happens inside the functions. Okay, so the last new concept is return. We talked about that. Okay, let me have some water. Okay, so the value tree is passed to the function, and the function body will be executed. The Python interpreter arrange the value tree. Let's go to read it. We don't need to read it. Take the value, work on the value, whatever is inside, calculate something, and return the number, which is 9 in here in this case. Okay. In this case, it takes 4 and generates the square of 4, which is 16, and put it to x again. And that's a good example to know we can reassign, we can change the value of a variable. The variable x, it was 4, but after the calculation, a square returns 16 as the square of 4 to us, and we assign that value to x in here. It is okay to do that. Another example, we have two friends, John and Jenny, and we want to sing for them happy birthday time. Okay, you know that's the happy birthday time. Happy birthday to you, dear John, and again happy birthday to you. And we want to create kind of a space line in here. Print can do that for us. Print empty is a space line for us in here, and then we want to do the same again for the next person in here. So see, I have repeated this line of code 8 times. 4 times for here, 4 times for here. So let's see if we can do that with the function definition. Let's define a function which is happy birthday. And usually in the naming of the function, we try to consider a name which is meaningful, not only for the function but also for the variable. For example, in this case, we can say apple / parentheses name. That's okay. Python accepts it from you. But if someone wants to look at the name of the function and your code in terms of readability, it's not readable that much, because what is the function apple? What does it do in here? But when you put exactly the happy birthday, the reader looks at the name and says, probably that function should do something about the happy birthday. It should be related to that thing. So please consider the meaningful names. Okay. So I will put these things inside the function. I'll take a name of the person. I'll print to happy birthday to you in here first, and then another happy birthday, and I will concatenate the name plus a dot. Why? Because I want to say happy birthday, dear Jenny dot. Okay, so that was the name. Happy birthday, dear. See, you have considered the space in here. If we didn't consider the space, we could add with the comma, with the quotation mark ourselves. But already we have considered that space in here, plus the name of the person, which comes in here, plus without any space or something, dot in here, which comes in here. Okay, and then another happy birthday. So easily we can call these things. Compare these 3 lines of codes with this 9 line of code. It is much more beautiful, simpler, easier to read, and so on. So that's the very good example that shows us why we are interested in the function. And if you print this program, it would be say something like that. Exactly. Happy birthday to you, John, Jenny, and one line of space in here. That was a good example of the function. Let's have a look at another example. It is common to have to reverse the order of elements in a list. We reviewed actually that example earlier. Rather than rewriting the code for this every time it is required, we could write a function to do it. So let's say we want to encrypt the content of the, let's make a real world example. That's something really I'm using in my teaching all the time, in my lecturing all the time. I try to bring real world examples to let the student know, okay, it could be usable in something interesting way. Okay, so let's imagine we have a text file and we want to encrypt that text file. What does it mean? It means if someone opened the file, they cannot read the content of the file. Instead of being hi, hello, how are you doing, etc., which is very meaningful, let's mix up the characters together, and so if someone opens the file, it is kind of, it doesn't make sense at all. What are these characters together? What do they mean? So that could be a real world example. So changing the content of the words, maybe. Okay. So, and you can have an algorithm. Okay. Julius Caesar, in the, you know him probably, in the wars at that time, they have kind of the encryption system for the letters they used to write, and it was maybe the first encryption system in the world. Easily they used to reverse the characters. For example, if you have 26 characters in English, they used to substitute any character with corresponding character from the reverse direction. For example, if you had a character A, they used to bring Z instead of A, put Z instead of A. If you had B, they used to bring Y and put instead of B. So that could be a very simple, maybe probably the simplest encryption system in the world. The first encryption system, at least it has been. Okay, so that could be a real world example. What if I have in my file, in my letter, I have 100 words and I want to reverse all of them? So what is the code that reverses the characters inside the word? Maybe 5 line of code, 10 line of code, and I'm facing with 100 words. I want to repeat that 5 line of code 100 times. That's crazy. So definitely I need to define a function. So that's a good example that shows us what happened. So we are facing with this, we can define this. So define a swap function which takes a string and then 2 locations. I will say I'll put the location I of that character, put it in a temporary variable, then I will take the J location of the string A, list A, whatever, put it in, replace it instead of inside for actually the I location. And then what about the I location? I location should come to the J location also. I had it already in the temp, so I can put temp in here. So I have defined a temporary intermediate variable as a temp. I take the I location to temp, put the J location to I location, and put the temp value inside the J location, which was the I location already. So this function substitute the I and J characters for me. Okay. And so to reverse the list, how to reverse the list? So I have a list of, let's say, 5 different things inside the elements inside the list. Okay, I want to reverse. I want to bring the last one instead of the first one, the one before the last one instead of the second one, and so on. So that function can do that for us. We define a function which is called reverse. The counter is 0 again. The counter is 0 again. I will say while I is less than length of A divided by 2, I'll swap these two things. I'll take inside A, I'll replace A, I, and the last one minus I minus 1. You remember when we wanted to reverse the direction of characters inside the string. We used to say print the length of A minus, prints the length of A minus I minus 1. Okay, we used to do that. So, and we will increase I in here. That should be a plus sign again. I should change it to plus. So that could be the function. We use a helper function, which is swap. This swap swaps the element in the 2 position in A. This is a good candidate for the function because it's self-contained, clearly defined operations. When we have a reverse, so that's a good example. Inside the file, let's say that file is test.py. Okay, inside that test.py, I have defined 2 functions, and then maybe I can add some line of code to use both of these functions. Okay, so you can define multiple functions to do that, and even you can use one function inside another function. That's a good example. We have defined swap first of all, and then inside the definition of the reverse, we are using the swap. But swap definition should be upper than the reverse to make sure reverse understand and know that. Okay, in here. So A is something, then we can reverse it, principle. So that would be a good example. You can implement it yourself and you can see how it works. Test it, look at the output to see how it works. Okay, let's have a look at the principle. Where we are, how much time do we have? We are going to the end of the class. We should speed up a little bit. Okay, so yeah, we don't want to review these things. We have talked about them already. So what is the modules? Sometimes we have lots of functions, okay? We have more than one file. We have a project in our Python code, for example, and we want to read the input from some files. We have some functions for that things. Also, we want to calculate some average, standard deviation, variance. We want to do some statistical stuff. We will put that inside another file. We want to do some other stuff. So we categorize and separate all these things in different files. So we have file 1.py, 2.py, 3.py, and so on. Okay, and we want to use all of these functions inside the main function. This case is called modules. What does it mean? It means I can define, for example, arithmetic.py function file. Inside that file, we can add some function, and then we can use the function we have defined already inside this function inside a new file. Sorry, inside this file function we have defined already inside this file inside a new file. How we can have access to that? This case is called modules, and we need to use import. Using the import, when I say import arithmetic without the name of .py, that means I will have access to all the functions I have already defined inside this function. Okay, so if I want to calculate add, let's add is something which adds 2 things, and multiply is something which multiply 2 things. And then inside the test.py, I import arithmetic first, and then I will say print arithmetic dot add 5 and 6, arithmetic dot multiply 5 and 6. Okay, calculates that for us. And sometimes I may want to say I want to get rid of, see in here, that's a little bit crazy. You say the name of the file, you have defined already the codes, and then the name of the function. You might want to get rid of that. That's one case. The second case is maybe you have defined 100 different functions inside here, but you might want only 2 of them. You don't want to use all of those functions. So you can go this way. You can say, instead of saying import arithmetic, you can say from arithmetic import add and multiply. So that means only I need to use these 2 functions. If you have other functions, I don't care. I want to use only this function. Okay, so then this way even you don't need to say arithmetic dot add. So just simply you can say add, multiply, you can use them, because by that way you can say I have access to add as it was defined inside in here. Okay, easily you can go for that. So that's a very good case. And also another simple case, another case which I have not referred to here, is you can rename it. For example, if the name of the file you have defined already is arithmetic.py, that's a long name. You don't want to repeat that all the time. Say arithmetic.add, arithmetic.multiply. And sometimes, okay, so you might say if the name is too long, just import whatever you want. Okay, I have 100 functions defined in here and I need all of them. So I need to have something like that. I need to import like that. But that's a line name. Here you can do a trick. You can say import something as another name. For example, in this case, it could be import arithmetic as AR. So you have renamed that function. So here you can say print AR dot add blah blah. So you can rename it. So when you import it, you can rename the file and make it shorter, and it would be much easier for you to use it. Okay. And so that's and sometimes the function, the module you have defined the function inside, you can run it as a code also. Sometimes it might be only the functions, and sometimes like this case, it could be an executable file by itself, like in here. So this part of the code will help us to see if this file that we have defined already is an executable code or it is not. How we can do that? Using this part exactly. What you put here, let the file know, let the interpreter know if it can execute this file or not. Let's go to see what happens in here. So if you put main, in here, okay, if you put main here, what does it mean? It means you can execute the file. You can say Python arithmetic.py. What happens? Okay, we have the definition of the file in here, and at the end it say print add 3 and 4, print multiply 3 and 4. Okay, it does that for us. Okay, but if we put, instead of this main, we put something different, if you don't consider that, put that, let's have it, where was it? In here, the Python to be immediately set a special read only, the name, the name of the module, if it is being imported into another module. If we put only the name instead of the main, if we put the name, then what would happen? This function cannot be executed. Again, this guy can be executed by itself, the geometry. I have defined the circle area and the rectangle area inside that. That file also is executable because of that. So I can import them inside the geometry and print it. But if I substitute this guy with the name of the file, that means I cannot execute it. That would be false, and it cannot be executed. Okay, so let's recap what we talked about today. We talked about the loop. We went through some loop example, while loop example. We saw different cases. We talked about the strings. We saw what would happen inside the strings. We have different things. We can concatenate them. We can play with different location, etc. And then we move to function. We talk about what we are interested in defining the function. We talked about what are the elements of defining the function, and also we said the function has a return, which is very important, and showed some examples, and example like this, which was very helpful and interesting. And then we went toward the modules and say sometimes we have loads of the function, we want to define those functions inside another file and then call it inside the function we have. So to do that, we said we define them in here, and then we import the function, the file inside something,